This airplane is landing and it has an angle of depression of, let's say, 5 degrees, okay? And this is not drawn to scale, so don't worry about that. The angle of depression is the angle that it forms with the horizon. So that would be 5 degrees, okay? This is called the angle of depression. Everybody get that? But that angle isn't inside the triangle, right? So the one inside the triangle, those two would add up to 90 because that's a vertical and a horizontal. It would be 90. So it would be 85 degrees would be that one at the top, okay? But the angle of depression would be 5. Everybody understand that? Well, guess what? The ground and the horizon form parallel lines. You see that? So what do we know about this angle right here? This one. How much does that measure? This green angle down here would also be 5 degrees, even though it's not drawn to scale. Remember that. It would be 5 degrees because they're alternate interior angles. Well, this guy here is your angle of elevation. So when you're dealing with a triangle, the angle of depression and the angle of elevation are going to have the same measurement. So if they give you the angle of depression, put it on the floor, right here. If they give you angle of elevation, put it on the floor, right there. And then use SOHCAHTOA to solve the rest. You understand that? Because they're the same. No matter what they give you, just put it on the ground. Not the right angle, but the other one that's on the ground. You understand that? The angle of elevation is if I'm standing right here and looking up to the plane, I would be looking up at an angle of 5 degrees with the ground. Do you understand? Yeah. But it's the same thing he's looking down on me at 5 degrees looking towards the ground. So it doesn't matter which one they give you. And for a long time, I didn't understand that when I was a student, okay? And I was just like, now they gave me the angle of depression. How do I use that? That's not even in the triangle. But it is. It's the same as the guy on the ground. Okay? So I have an airplane that's got an angle of depression of 12 degrees, and there's a tower of 150 feet up in the air. And there's a guy at the top of the tower, and I don't draw anything very elaborately, but it's drawn very elaborately in my book. But I just draw like a pole, and he's up in there. And he can see the plane, and the angle of depression is 12. So we know that this angle here is also 12 degrees. Now they want to know the distance that the plane is to the base of the tower. Which side of the triangle do they want?
The bottom.
The bottom side. They want this right here. So I'm going to put an X there. And now we're going to use SOHCAHTOA. SOHCAHTOA is going to be used for all of these. And we're going to say to ourselves, all right, here's my angle. X is the adjacent. And 150 is the opposite. Which one has an A and an O in it?
Tangent.
Tangent. So we say tangent of 12 degrees equals 150 over X. Everybody understand that?
Yeah.
Yes.
Opposite over adjacent. We cross multiply and we get X tangent of 12 equals 150. And divide by tangent of 12. Do not pick up your calculator until the X is alone. Got it? Mm-hmm. So it's 150 divided by tangent of 12. Okay, so it's 705 feet, 0.69 feet away. And that makes sense, right? Because that angle of depression is only 12 degrees. It's going to take him a while to get down from the tower. He's got to be far away from the tower in order to be able to take off and not hit the guy in the tower, right? You a picture and they want you to show me the angle of depression or the angle of elevation. What I want you to do in that picture is this would be the angle of depression, put a D there, and this one would be the angle of elevation, put an E there. Do you understand what I'm saying?